hear me. All right. All right. Now let's see if Deb, you can advance the slide. And there it is. Okay. Well, thank you everyone for listening. Hopefully you can you can hear me and you can see the slide. I'll start here just by saying that I wanted to start with a slide of some bad news, and that's that Baja is moving towards Oregon, and it's doing so over the next 50 to 80 years. That one of the tools it has to get there is fire, drought, and we're seeing the results of that. More and more drought, more and more large fires, and that's all fine and good if the fires that burn the forests in California, if all the forests regrow. But we're not seeing that in California. We're seeing a massive change in the type of vegetation, which forests are turning to shrublands and so on. And so we're seeing the results of climate change, both in forests in California, but also in urban forests in California. Next slide, Deb. And we can no longer grow and plant, or should plant, the trees we always have. These maps here that you've probably seen before, they show changing hardiness zones over the 25 years between the publication of these Arbor Day areas in pink and red, areas that have shifted to warmer climates. Well, the warming and the shifting of warmer climates is happening all over the place. And in general, in a Mediterranean climate in Western California, that means hotter and drier. Next slide. California. And these are recently published maps from NOAA showing how much of baseline climate has shifted in California since 1895. And it's also just predicted to get warmer and warmer. In a Mediterranean climate, like I just said, warmer means drier. And so we're seeing drier and drier. So we need to start to think about drought tolerance and trees in the urban forest. And all of this warming and drying and more extreme events, next slide, Deb, leads to, in California, a loss of trees. And we've seen that in the last decade. We've lost nearly 5% of the total trees in the state. And that data is for previous to 2018, could be upwards of 8% of all the trees in the state recently, due to large fire events and then not replacement of those trees. We're experiencing a new reality. And that new reality has got a precarious future in which our trees in our urban forests are under threat of the changing climate and the results of that changing climate. Now, it's important that people have trees in cities. We all know that, and it would be preaching to the choir for a conference like this for me to tell you that trees are important for people in cities. And cities are such changed environments that we can't just pick trees that we think are going to work in forests around those cities. We have to have very specific types of trees that survive in the changed environments in cities. And trees have all kinds of benefits for people's lives. Next, Deb. We know that they cool cities. The shade that trees provide cool cities in many different ways, and we have some recent data that we're about to publish showing that diverse forests cool cities even more. But having a full canopy can provide cooling of up to 10 degrees in some neighborhoods, and that's been shown in neighborhoods with relatively low vegetation cover are demonstrably warmer. Next slide. And because of the warming tree, go ahead and give me the next slide. There you go. The trees can reduce energy consumption. A full canopy can reduce energy consumption by 25%. Urban trees can promote wildlife. We all want to live with wildlife, and this figure shows bird censusing. And this is work that's happened over and over again in different cities. This data is from Seattle, that if you want birds, you need a maximum of 5 mature trees per acre in a city. And next slide, Deb. We know the trees make people happy. I mean, a number of published studies, people surveyed on the measurements of well-being and their own perception of their well-being. is increased when there's more trees around. Next slide. So all of this adds up to a very simple thing, is that if you try to have cities without trees, people are going to live a lower quality life in those areas. And so, how do we continue to have quality canopy cover in our cities when, and specifically in California, where we have 40 million people? People are living more and more and more in urban areas. The wildland urban interface is increasing and increasing. How do we increase the canopy cover, quality, diversity, and resilience of the urban forest? Next slide. And what does success look like for urban forests? And so, in thinking about what success looks like for urban forests, especially in the 21st century, in a time of climate chaos and biodiversity loss, I'll define success for our urban forests in a number of human benefits coming from the urban forest. That's things that I defined earlier, things like aesthetics and health and feelings of well-being, all the quality of life stuff. But also we need to think about carbon sequestration and reuse of wood once it's sequestered into the bodies of trees, and also conservation of biodiversity. All these things have to come together to make successful planting. And if we define successful tree planting as having a component of each of these, then which things converge to create that, next slide, is species selection. Next slide, Deb, and site conditions. And species selection and site conditions interact to make for successful tree plantings. And the point I'm trying to make up until now is that site conditions are changing. Site conditions are changing as the climate gets warmer and drier, and so our species selection needs to change. We need to really focus on species selection. What are we growing? Why are we growing it? And what is its end of life wood usage like? Because we know we can no longer put things into a chipper and rot them and so on. And so, what species are we growing? Because changing the site conditions for successful tree planting is expensive and untenable in most situations. So species selection is something that I find to be very important. And my colleague Jeff Reimers and Jen Yost and other people here at Cal Poly, we run this website called Selectree. Hopefully you guys all know about it. We just are in the process of redoing the entire site, redoing a lot of the data. Deb, go. Just you can have all that text come up. I think there's 4 bullet points there. It's showing that Selectree is an interactive tree selection guide. We now have over 1,500 species, adding species to it constantly, as we know that different species become more important in the urban forest. We add species and all the data. For all species, we have up to 75 characters for each of those species. And now we have about 10,000 photos of all these trees on Selectree. And so tree selection can begin with understanding what are the characters of the trees we want to select, and hopefully Selectree is a useful tool for that. Go ahead and give me the next slide, Deb. And as many of you know, with Selectree, we can do species selection based on searching by those characteristics, and many of the characteristics are searchable. We have discussions all the time about which characteristics should be searchable and which ones shouldn't. Obvious things like tree height and so on are important searchable characteristics, but other ones, and go ahead and give me the next slide. We have all kinds of characteristics, things like salinity tolerance or drought tolerance is a good example of a tree characteristic, which you should be interested in selecting for when planting a tree. Now, with regards to this conference and end of life wood usage for urban trees, one thing that I want to ask everybody about and talk about in general is there a database for the best urban wood species in California? What are those? How are we judging the urban wood species? And if so, can we get that data and upload it to Selectree so that people can search for when planting a tree, they can search for the quality of the urban wood. And I know ways to do that, but the actual data, I would like everybody here as a group of experts to come up with that data for the public that way. Let's go to the next slide. And a good example of the way that we come up for select it, this is as an example, can we use the native range that we know of species to predict water usage? And water usage is another thing we're now presenting. Looked at the native range climate parameters for about 350 of California's most commonly grown species, and we calculate the mean annual precipitation and temperature. And this is just two examples. You can imagine the Joshua tree, which occurs in the Mojave Desert, and the northern catalpa, which grows natively in the Midwest, only at the confluence of the Mississippi and Ohio rivers, that they would have, these two species evolved in very different precipitation and temperature conditions. So they're going to behave differently in the California urban forest. And so can we find and use the native range information for all the species and then make predictions about which species will be more drought tolerant? We think we can. And so what we've done is we've done that. And go ahead and give me the next slide. And on SelectTree, now we're presenting and listing water use ratings based on somewhat on expert opinion, which is what WUCOLS and that information is based on, but also by modeling the native ranges of species and using that to predict their potential in doing the climate modeling, as well as leaf characteristics to figure out what are the water use ratings for species. And now you can go on to SelectTree. You can select for low, very low water use ratings and come up with the species that have those ratings. So I'll take the next slide now. I'll transition off of SelectTree and just say that there are a lot of different trees in the world. We all know that there's 300,000 or so plant species, about 60,000 species of trees, and we grow about 7% of those. You can give me the next slide, and you can advance it one more. And what you can see graphically there is that we of the 60,000 total species of trees in the world, we grow about 7% in all the world's urban forests, and a much smaller number than that in California's urban forests. And the question that I'm interested in is can we do better? Are there species that we aren't growing that are drought tolerant, make great wood at the end of their life and can be used, and the wood can be used and will grow well in California's cities, and that we're not currently growing? And the answer is, I'm sure there is, and we're looking for them, and we're trying to go to create projects in which we can figure out and test species as to whether they'll do better in California's urban forests. I just returned from a short course teaching trip to the south of France at the University of Montpellier, and I flew in and out of Barcelona, and I spent a day in Barcelona, Spain, which is a very Mediterranean, and there common tree species in the city of Barcelona is a species called Celtis australis. Celtis australis is a European hag all over that city. And that's a species that's relatively uncommon in California. Why are they growing so much of it? Why does it do really well there in a climate similar to someplace like Los Angeles? Yet you finding Celtis australis on the streets of Los Angeles is nearly impossible. So are we growing everything we should? Are there good species that we're not? The answer, I think, is yes. And can we find them? And that is one of the projects I'm working on that I want to talk to you about today. Is trying to do. And so before I do that, I just want to mention that we've also created and developed another tool. Go ahead and give me the next slide, Deb. And this is a tool to look at California's urban forest in a way that you could never look at it before. And we've gathered inventory data from our partners at West Coast Arborists and A+ and Davy and CAL FIRE, and we've aggregated all of that together on this website. It's nearly we're about 8,000 data points short of 7 million data points of what trees are growing where in California and what size they are. And when you have that many data points of that many species, you can answer so many cool questions about what current diversity is in cities in California. What are we growing? And then you can begin to answer questions about what should we be growing, what do we not have that we should be trying more of. And so 7 million data points. What do 7 million data points tell us about what is the world's largest and most diverse urban forest? First of all, it has told us that it is the world's largest and most diverse urban forest when we compare it to other data sets elsewhere. And then I'll take the next slide. And here is showing you the extensiveness of this data set that I'm going to show you some results from. First of all, almost all urban areas in California are pretty well represented by many data points, and you can see that on the left and right. And on the left is the climate zones that we've used to show different areas of California. We got some black dots and red dots on there. The black dots are areas where these are 83 cities that are really well inventoried. They have over 20,000 data points in it. And the red points represent the top 10 most species rich cities. And I'll tell you a little bit about that. Go ahead and go on to the next slide. And we have a really high record density for the Los Angeles and San Diego and Bay areas. And so what that tells us is that we can actually learn some things about the urban forest based on all this inventory data. And I'll tell you what we know so far. So go ahead, Deb. First of all, this is a heat map showing the density of urban tree species in California. So as you get away from San Diego and Los Angeles and the Bay Area, specifically San Francisco and San Jose, the density goes less and less and less of different species. You can see the colors equal. Dark blue is that the places in dark blue there have between 246 and 332 different urban tree species growing in that area. Go ahead. And we know now what are the most abundant species in California. Crepe myrtle, that's Lagerstroemia indica, and its hybrids and cultivars make up 6% of all of California's urban forests, being the most abundant tree species in California, followed by the London plane tree, the Bradford pear, and then the California fan palm, and so on. And you can see the list there of these are the most commonly grown urban trees in California based on this 7 million data point data set. Go ahead, Deb. And interestingly, we know that the DBH of a huge number of the species in this data set, it's a huge number of individual trees in the data set. And what you can see is that most trees in California's urban forests are small. And on the left is the diameter at breast height in inches. And these are binned into different categories, 0 to 6 inches, 6 to 12 inches. You can see that Lagerstroemia, obviously, which is a small tree, has over 260,000, so 250,000 of them that are between 0 and 6 inches in diameter. You can also see that other species are larger, but for the most part, trees in California's urban forests are somewhere between 6 and 18 inches in diameter. We also know now really accurately where the trees in California's urban forests come from, and these are native ranges of all the species we can find in the urban forest. And most species in California urban forests are from Asia. That's 26% of them. Australia and North America, excluding California. And this figure here was generated from the California urban forest inventory species. And what we did here is we just removed all species that occur with fewer than 1,000 records. And so we did that so we could actually see where most of the species are coming from, not really rare things. And then on this, we can look at some really cool things about what, how do you compare cities? What cities are more diverse than others? Where is the urban forest in California more diverse and less diverse? And so if we look at go ahead in the next slide, species per city. On average, how many species of trees are in a city in California? Well, the average is about 234 species, and that's that red vertical line right there. But it's a normal distribution out on the large end at Los Angeles, with 396 species found, and this is excluding species with fewer than 1,000 records. So this is very commonly occurring things, or things that are actually occurring with more than 1,000 individuals. That is 396 species. That's a lot for Los Angeles. And then someplace like Tracy is on the other end of the distribution with 135 known species. So there we go. There's the next slide. This is the relative abundance of the most common species. So high numbers in this case, things over to the right there, mean that there's a high abundance in the urban forest, meaning that species are less evenly distributed, and the city is over-reliant on one or likely just a few species. As an example, you can see the city of Cerritos or Mission Viejo. They have nearly a quarter of all their urban forest is in one species. In the case of Cerritos is Pyrus caleriana, the Bradford pear, and then the coast live oak and Mission Viejo. On average, though, the most common species in a city makes up about 12%, about 1/8 of the entire urban forest. And, that gets as high as almost a quarter, and the ends there to the right. So 12% made up of one species for most urban forests in California. And then if we look at the species diversity, go ahead for the next slide. We created an index that we call the CS50 Index, and that's the number of species that make up half or 50% of the trees in an urban forest. How many species make up half of all your urban forest in your city? And it's an interesting measure, and you can see that over to the right, at the high end, there are a city like Santa Cruz or another city like Ventura. They have 16 species making up half of their urban forest. And on the low end here, there are some cities there with 2 or 3 species that make up half of their urban forest. So in general, on average, somewhere around 9 or 10 species make up half of all of the urban forests in cities in California. Go ahead, next slide. And you can just give me all those, the bullet points there. There they are. And the point I wanted to make here is the diversity that we're seeing in the California's urban forest is actually a legacy of the past. What we find is that 234 species on average are found in California's urban forest. But when you look at all of the approved planting lists, and we've looked and we've pulled together all the approved planting lists, and this was also published, slightly different numbers, but published by Bob Moeller and Carol Bornstein in 2010, we see that on average there's about 50 species on California municipality approved planting lists. So you have 234 species in the urban forest. Your approved future planting is 50 species, or 21% of existing species are approved for the future. And the other thing to remember is that a lot of those approved species lists, they could be really inappropriate for the future of California because of the changing climate in California. So go ahead and give me one more slide here, and you can just go through that. And I want to make the argument to you that species diversity is really important in California, because new diseases, we see that they tend to be species specific, and diversity of species in an urban forest leads to more resilience. We should be thinking about how do we increase the resilience of our cities, of our lives, of our urban forests with regards to what's coming in the future. We have massive changing urban conditions in which cities themselves are getting hotter and drier. And we need to have increased the utility of urban forests. We need new habitats in urban areas. If the population of California and other places becomes more and more urban, diversity means more cooling. We're seeing that now. The explanation for that and the results that we see, that the more diverse a place is, the better the heat island cooling effect is because of potentially many different shapes and heights of leaves leads to more and better cooling. And diversity is beautiful and it's more interesting. So in addition to being resilient, it gets more people to be interested in the urban forest as well. So with all that as the background, the project that I'm involved with, it's called the Circle 4 grant. Go ahead and give me the next slide, which is the title slide about that grant. And this is a collaboration between West Coast arborists and several other organizations that are there, including wholesale nurseries and funding organizations and Cal Poly. And this is a grant to plant and monitor underutilized trees in the urban forest. And underutilized trees, we know what they are now because of the inventory data that I've showed you. We know what is in California, what's common in California, and what we should be trying to see if it works well for the future of California. And not only can we try species that work well for the future based on climate and climate modeling for the future of California, but we could try species that work well for their end-of-life wood usage. Go ahead and give me the next slide. So the way we went about this is we picked different species for different areas, different regions of California. We made lists of species that were not common in California, but worked well in climate modeling, were from hotter, drier areas, and could potentially do well. And this is a list of a lot of species, but I'm just going to highlight a few of them and tell you why we've targeted those few for this project. Go ahead and next slide. And what we have and what we've tried is 4 oak species, and we're targeting 4 oak species to plant all over California that are from Texas in the Southwest, so drier, hotter areas than California. And one of those is Canby's oak. You can go to the next slide. A really beautiful species from the Chiricahua Mountains in Arizona and other parts of western Texas, the silverleaf oak, Hypolochoides. Go ahead. Quercus oblongifolia, a relative of the California blue oak, a very drought-tolerant oak tree that could potentially do well in urban places. One more, Deb. And then the last of the oak species is Quercus rugosa, the netleaf oak, another white oak relative from very dry areas that not only makes good white oak type wood, but also could potentially live in a very dry, drought-laden city areas and still get to be a big tree. Now, if you're interested in drought tolerance and species that can do well in city environments and thrive on neglect, you have to think about Australia. Go ahead and give me the next slide. Australia is, as many of you know, it's the hottest, driest, flattest. It's also the oldest continent in the sense that it's been above the ocean longer than any other continent on Earth. And so trees that have evolved in Australia have evolved in terrible conditions and very hot, dry conditions that mimic street tree planting wells in cities. So that's why Australian trees, first of all, they do well in California. And also we could potentially have other Australian trees that are underutilized and they would do well in California and they would potentially make good wood. Wood is important and woodworking is important in Australia, and they've been using all kinds of Australian woods for a long, long time. And so in California, we planted the blue gum all over California with attempts to use that for for forestry products in the 1800s, and it failed because the blue gum is inappropriate for most parts of California. But there are some species in Australia that would do well in central and southern California, and could be good urban trees, but also would produce good wood. And we're focused on some of those, and a couple of Australian trees, eucalyptus and their relatives, that we've focused on in this project is Eucalyptus cinerea. Go ahead and give me the next slide, Deb. It's a picture of the silver dollar gum, or also called the Argyle apple. It's got red, very soft bark and a blue canopy. Go ahead and give me the next slide. There's the swamp gum, Eucalyptus spathulata, with its needle-like leaves, and also a very drought and salt tolerant tree. Next slide. And after that are two eucalyptus relatives that we're focused on, the beautiful Angophora costata, or rose gum. It's an underused. It's got copper bark. It's a copper bark tree. It's closely related to eucalyptus, and this is for bigger planting areas, but are beautiful trees. Potentially could replace Corymbia citriodora in the areas where it's very heavily overplanted. And then next slide, there's the red flowering gum, which is it's native to Western Australia. It's a desirable flower accent tree. It was more popular in California in the past, and it is rare and endangered in the wild in Australia and the small native range that it has, and it tends to do very well in coastal areas and dry coastal areas. Another group of trees, go ahead and give me the next slide, that we're focusing on are legumes. And some facts about legumes for you is that, first of all, the legume family, that plant family, the Fabaceae, is probably the most economically and ecologically important plant families in the world. It's the third largest plant family. There's about 700 genera and maybe 20,000 species of legumes, more trees than any other plant family. They fix nitrogen. They make really highly valuable crops for us, obviously, things like peas and beans and lentils and chickpeas and all of that, and come from legumes. They also can make really valuable wood. And the examples that I gave here are 4 species that can grow in California, do grow well in California, are very drought tolerant trees. And that's on the upper left is Indian rosewood, or Dalbergia. And on the upper right is the blackwood acacia, a tree that was popular and grew very commonly in California, is less so now. That's Acacia melanoxylon. Acacia koa in the bottom right-hand corner, and the Brazilian ironwood, which was Libidibia ferrera. Libidibia used to be in the genus Caesalpinia. And so those are 4 woods that are being targeted by this project. And I'll go ahead and give me the next slide. And you would think that Acacia koa may not do well in California, because first of all, Acacia koa is endemic to Hawaii. It's one of the most valuable hardwoods now in the world. Well, Acacia koa, as it turns out, especially collections of Acacia koa from higher elevations in the Hawaiian Islands, do really well in California and grow fast early in their life. They slow down and grow very slowly, which is typical of leguminous trees, or at least many different types of leguminous trees grow fast when young and slower when they're older. Acacia koa is one of those, and it makes really beautiful wood, and is also turns out to be potentially a good street and shade tree for California. Another example of a tree that's grown in drier areas in the world is Dalbergia ciso, also called the ciso tree, or the or Indian rosewood. These pictures of it here I took in Phoenix. It's a really commonly grown tree in Phoenix and Tucson, and we should be growing more of it in California. It's horticulturally, it's a good shade and park tree, but it also has really beautiful wood and could potentially be used at the end of its life. And these are just some of the many trees that could be targeted for the future of increasing diversity in California's urban forest. And that's why I'm excited about this Circle 4 project. We're planting all these trees coming up in 2022, and we're going to monitor them for many years after that. We're going to try to figure out which ones do well, which ones don't, and how can we increase the diversity in California's urban forest, plant new trees. Well, that takes involving a whole lot of different groups, including nurseries, to grow them, and then getting them out into the landscape, figuring out if they work, and then increasing our resilience and and hopefully end of life use. And so with that, it's let's see, it's 9:05, and I'll say last slide, Deb, back to the title slide there. And a lot of people were and have been involved in this project with me, including, I'll say thank you to Mike Pallett and Andy Trotter from WCA for their vision on this, and they brought me in just to help them figure out what species to do. But it's their idea to grow cool underutilized trees in California that could potentially be used for wood in the future. And so I'm happy to be part of the project. Also, thank you to John Melvin and Walter Passmore for continuing to support this and other types of projects like it that I work on, and Select Tree and the California Tree Inventory Project, and Jeff Reimer, my colleague here at Cal Poly, and also my team here at Cal Poly, who does all this work with me. And with that, I can answer questions. If people put questions in the chat or something like that, I can answer them. Or I don't know if Deb, you want to moderate it, or however it works.
We've got some questions and we've got some comments. And people, if you have questions for Matt, please put them in the Q&A section, and then I can go ahead and ask him. So feel free to get those in there. So this is from Kathy. Are we introducing new pathogens to native trees by increasing diversity from other continents? And then part 2 of that is, do we know how quickly our birds and insects adapt to using non-native species?
Okay. Well, I'll address both of those by saying that, first of all, when we introduce new species to California in the horticulture trade, they get, for the most part, they get introduced in the form of seeds. This is true for leguminous plants and members of the myrtle family, eucalyptus and their relatives, for instance. So seeds, which are usually, well, when we treat them here, they're sterilized before germination. So there's very specific laws and rules about introducing species, and particularly species that live individuals with soil on them and so on, and that doesn't happen. And so the first part of the question, are we introducing new potential pests? Yes, all the time, but not in projects like this, not in the attempt to grow new species of trees. So and then what was the second part of that question?
The second part is, do we know how quickly our birds and insects adapt to using non-native species?
Yeah, no, we don't. And the other way I would respond to that, though, is that who cares? Who cares? We are we're facing serious problems where we need, in our cities, to have more trees, and we have about 50 years until life becomes like hell in California. And if we're going to get paralyzed by worrying about how well insects do on new species that grow well and provide shade and so on, we have to decide, are we trying to go for the quality of life of humans in cities, or are we trying to go for more wildlife? Let me mention that I think it's very important that we stop developing and changing areas where there's a high amount of biodiversity out in the wild in California. But in cities, it's a very different situation. And so what we're talking about here is growing new species for cities in California, and problems of wildlife adapting to new trees, even problems of weediness in California from species that we introduce for cities, are very far down on the list of things we should be worrying about, in my opinion. And so although those are those are things to be thinking about, they aren't the most important issues. The most important issues are what trees will grow really well, provide a lot of canopy cover, sequester a lot of carbon, and make for good urban forests that protect people from what's coming.
All right, there's one other comment, Matt, and I'm sure this is not new to you. This is from Robin, we're dealing with a legacy of eucalyptus planting over 100 years ago in the open spaces of the Bay Area. And the diversity of wildlife is not there, so it is claimed or not supported. Why would we want to repeat that?
Well, okay, so why would we want to repeat it? What we are, first of all, when people say we're dealing with a legacy of eucalyptus in the Bay Area, that's totally true. There was blue gum was planted all over the Bay Area, and blue gum or Eucalyptus globulus shouldn't be planted again. It's an inappropriate species for most places where it was planted, and we're not planting more blue gums. There's 800 species in the genus Eucalyptus. Some of them are very small, well-behaved, non-weedy, very drought tolerant trees. Why would we ignore the use of those in cities because the blue gum was misappropriated and misplanted and problematic in areas in the Bay Area? Well, the answer is it would be dumb to do that, to just ignore things because of the fact that it shares a name with Eucalyptus globulus. Now, I should also mention that we need to be careful here as well about thinking closely about weediness and how wildlife interacts with non-native trees. As far as I know, and Robin and other people can correct me, there is a single paper published about wildlife usage of blue gum plantations versus coast live oak woodlands. And that says that the diversity of wildlife in those two are about equal. They're slightly different types of wildlife, and insects use one versus the other versus birds using one versus the other. But it's not just well established that non-native places have less wildlife. It's not what that's a nice narrative, but it's not necessarily true. And Doug Talamay would argue, I see here, that we would be better to care about insects because of our survival depends on their survival. And yeah, that's potentially true. And Doug Talamay, Doug, who I know well, him and I disagree on some things. That we, for instance, should be growing only native plants in California in our urban forests. It just won't work. It works nice where Doug works, where it rains during the summer. It doesn't work in California. It doesn't work in all our changed cities. And also, many of our cities, Los Angeles, San Diego, have very few to no native trees there. It's rolling hills of coastal scrub and chaparral because it's a Mediterranean climate, and they haven't had many native trees since the Miocene. And so if we wanted to say that we only want to plant native trees for wildlife, well, we don't have very many. I'm sorry, but we don't have very many. And so the answer, it seems to me, is that we are in an emergency situation in which we need more urban trees and better urban tree cover, and we're losing trees all the time. Well, what do we have to do? We have to go to a better plant palette for that. And what is our plant palette? Well, it includes California native trees, but it can't be exclusive to that. And we have to figure out ways to increase the quality of life of people in California cities, especially underrepresented people who don't have great trees to begin with. What trees can we grow that will thrive on neglect in all neighborhoods, not just rich neighborhoods? So those are things that are important to be thinking about.
Folks, I'm going to ask two more questions and then we'll move on. And I'm going to keep them more geared to urban to a certain extent, if possible. And I can send these other questions to Matt, and he can reply and we can get back to everyone on them. Okay, this is from Walter Passmore. What is your opinion about mesquite? It is one of the most stable and beautiful woods, plus the tree is very drought tolerant.
I agree. Yeah. And in Prosopis, there's a number of species in the genus Prosopis, Walter, as you know, that have the potential to make great trees for California. Very drought tolerant, slow growing, and interesting trees. A number of them, why prosopis is avoided oftentimes in urban areas is because of the spiny nature of some of the species, but spines have been bred out of some species of prosopis, or they're not existence on there. So those are potentially very good urban trees. So that's a good question. And yes, I think that mesquite should be considered constantly. And it is in cities that are much drier than us. In Phoenix and Tucson, those are very common species.
Okay, and then Mel Sutton, he wants to know the oak species again. What did he say? The presentation went from Campbell to rugosa, didn't seem to change for him, so that apparently the slide got frozen. And we are recording, folks, so this will be available later as well. Go ahead. Do you want to answer it? I'm sorry.
Oh, sorry, Nancy. Can you say that? You broke up. Can you say that question again?
So Mel is asking if you could list the oak species again that you recommend.
Oh, yeah. The oak species that are Quercus rugosa, that's the net leaf oak. There's Quercus oblongifolia, which is the Arizona blue oak. I said that one is related to our California blue oak. And then there's Quercus hypolicoides, which is the silver leaf oak. And the last one is Quercus cambii, Camby's oak. All of those from drier areas of southwestern North America and have a potential to be great species for California.
Okay, Matt. Thank you. Don't go away. We're going to have your actual award presentation now. I want to just remind everyone, we will get those last few questions answered and sent out to everyone in the next few days. So California Urban Forest Council is peppering our annual awards throughout the day today. And Matt is one of the Excellence in Education Award winners. And I guess we all can see why, just based on this presentation today and how he is moving the ball down the field for California and urban forestry. So the person who submitted Matt's application for the award writes, Dr. Ritter is educating not only his students, but the tree care industry with the tough climate situation California is in and trees that are ideal for that change. He is an author, researcher, and professor, where his passion for California's ecosystems and biodiversity is shown through his involvement with academia and in the industry, like the work he is doing with us now at California Urban Forest Council, along with West Coast Arborists Incorporated. And before you speak, I just want to let everyone know, is this?
That's it.
All of our award winners are going to get a copy of Richard Liu's Our Wild Calling and the new bandana, the peanut gallery here. And we also are having cutting boards made out of recycled urban redwood from and donated by Bay Area Redwood. So thank you. We like to acknowledge the best we can. And Matt, would you like to say a few words?
Yeah, well, I'll just say thank you, Nancy. It's an honor to receive this award. I have come to the California urban tree world as an outsider, as a botanist who is in love with trees and wood and so on. And in that time over the last 15 years of working with everybody, I've met so many great people and very smart people who are very forward thinking with visions about how to make California better. So it's an honor to be part of your group, and thank you again for the award.
We thank you. And now we're going to go